Select the missing reagent required to accomplish the following transformation. So if we take a look at the starting reagent, we see that we have a Grignard reagent. And we know that Grignard reagents are really strong bases as well as powerful nucleophiles. So we are going to, we appear to be adding extra carbons, so we need some kind of electrophile here. So we want to recognize what we have from our Grignard reagent. So we essentially have something that's going to act like a carbanion. So we can draw that out really nice and clear. And then we want to look at where those carbon atoms are in this product so we can kind of backtrack and see what we need. So we see our cyclohexane ring, and then we can see that we have the CH2 there. So the other carbon atoms here, so these 1, 2, 3 carbon atoms have to be coming from your electrophile. So one thing that we could do to solve this, and this is what I like to do, is I like to redraw that product. Okay, so there it is. And we want to recognize that if these are the carbons that were coming from your Grignard reagent, that this here is your new bond, right? So we know that new bond is going to form in the reaction. So we can backtrack by erasing that bond. So we've erased it. We know that this was the Grignard reagent, which tells us that this must have been the electrophilic carbon atom. And we've seen Grignard reagents react with carbonyls. So we're going to imagine that we had a carbonyl here, and that's what we reacted it with. Okay? And so we also want to recognize, so we've got that oxygen on there. We can draw this in on the product too. On the carbon where we're forming the new bond, we see 1, 2, 3 carbon atoms. So the fourth bond that we're not seeing is a hydrogen. So we do also have a hydrogen attached to that carbon. And so we've drawn it kind of badly. Let me go ahead and redraw it here. So we've said that we have this aldehyde and 2 carbon atoms, so 1, 2. And so now that I've got that redrawn, it's a good idea to backtrack and check. So you've got an idea that this is the right electrophile structure. Then to make sure, I would draw the mechanism and then follow those reaction arrows and make sure they're giving you the product that you want them to. So let's see what happens if we take this carbanion and we add it to this carbonyl and then break that bond. So what that's going to give us is we can see the cyclohexane, the CH2, and then our new bond, I'll put it in green, and then we have this carbon atom with the oxygen, right? So we push those electrons up so it's negatively charged, and we have a 2 carbon atom chain, okay? And so if we want to, we could draw the hydrogen in there, or we could just understand that it's there because that's part of the definition of a skeletal structure. So that'd be the product after the first step. And then if you add in the H3O+, then you will protonate that alkoxide. So we can say we've got lone pairs of electrons there, and it's going to grab that proton. And then we can hopefully see that we are getting the product that we wanted. So we've got that 6 carbon atom cyclohexane ring, the CH2 group. Here's our new bond, and these 3 carbon atoms. So 1, 2, 3, and we have the OH. And that is matching the structure that we were looking for. So this 1, 2, 3 carbon atom aldehyde is what we were looking for. So that is the answer B. And if you want some additional practice with Grignard reagents, this Grignard reagent will add to A to give you a different alcohol. It'll add to C to give you a different alcohol. It'll also add to D to give you yet another alcohol. So if you want additional practice, go ahead and see what the products would be if you added that Grignard reagent to those other 3 electrophiles.